Hello and welcome to the Video Surveillance Masterclass. Today we will talk about video stream components. I am Marcelo from Security Systems Center, a channel that brings you valuable information about video surveillance, access control and intrusion. I have more than 10 years of experience as an installer on my own and as tech support, as subject matter expert and a product quality tech support owner in a multinational manufacturer in the security system field. Today, I'm here to help you understand all the components that we have in the video stream. So let's start. When we talk about video stream, it's basically the information the camera is sending to the viewer or to the NVR. And this information is composed by many variables that we will see here in this class, such as resolution, FPS, bitrate and codec. And in the codec we will talk about the most used or most common codecs, the MJPEG, H.264 and H.265. And just remember, the cameras has not only one stream, but normally they have the main stream, which is the higher resolution one, and the substream, it's a lower resolution that you can use, for example, for monitoring only, and that if you choose to record in higher resolution, or the opposite, if you want to monitor in high resolution but just record a not high resolution video. Okay, so let's jump to each component to understand how we can set them in the better way to fit better in your project. Okay, so starting with resolution. Okay, so initially we'll cover the resolutions that we use in the analog systems, so analog cameras or even high quality analog as well, but basically are the initial, or in the early stages it was the ones that was most commonly used. So we will start with CIF, Common Intermediate Format. This format was created to be easily converted between PAL and NTSC. So how this CIF resolution works? So initially we have here this screen here. This we can call as CIF. And the number of pixels in the width and the height is 352 by 240. Okay. We have also another type of CIF, which is QCIF, which is half of the height and half of the width of the CIF. Okay, so this is QCIF. We have another resolution which is called 2CIF. 2CIF. And it's twice as the width that we have in the CIF, but in the same height. So this is 2CIF. And the last one, this major box, it's 4CIF. It's the highest resolution, which is twice as the 2 proportion of CIF. Okay, so that's just understanding what is the proportion between the CIFs. And basically we have this resolution currently in the cameras. Not all cameras, but a few ones will have this resolution. The most common one that we use for like substream, which is the stream that we don't have like a higher resolution is the D1, which is 720 by 480. And we have the 960, which is 960 by 980. So basically these are resolutions that we can consider more for analog systems, or very low resolutions that we can use in the substream. Okay, so jumping to higher resolutions that we can see today in IP cameras, or even in some high quality cameras as well, high quality analog cameras. So we have a variety of number of resolutions. And so we can start with the 720p. We have this, and I will put here in the graph just to show a little bit of proportion, and an example for K, right? So we have the 720p. It's still very used, this one. We have 1.3 megapixel. We have the 1080p. 1080p, it's widely used as well. We'll have the 2 megapixel camera, and then we will go up 3, 4, 5, 6, 8, and 12 megapixel 4K. So why we have so many resolutions available? So depending on the project, it's required to get more detail in the image, or if the camera is installed in a specific distance, it will not get enough detail if you have a low resolution, because in the end the resolution here is showing how many pixels we have in the image. So if we have more pixels, we'll have more details, more information in this image. Okay? And even if your monitor doesn't support like a 4K, for example, if your monitor support a 1080p resolution, you still can have a camera recording at 4K, and you can zoom in this image and get information like a face or a license plate or something like that. Okay, doing this digital zoom in, for example. Okay, and we have another component with this ratio, which is the most common is 4:3 or 16:9. So this will basically show the proportion of the image. Depending on the camera, for example, fisheye, if you're seeing the 360 view, you will probably have this view, or even like an equal proportion for all the measures in your stream. Okay. Okay, so let's jump to another component, which is FPS. So FPS is frames per second, so basically it's the frame rate this camera is sending information to the NVR or to the client. So as we know, in like movies, the movie is basically a sequence of static images, and it's the same concept with the camera as well. So we can have different numbers of FPS for each project, but the default one, the standard FPS will be 30 frames per second, which is a good value that will have a fluid view of the scene. So we'll not see any like a robotic movements or something like that. It will be a very fluid, but we need to recall that if we have more frames per second, we'll have more information for each frame to send to the NVR. So we'll have more data, more bitrate, and more bitrate we have more storage need as well. So we can have some installers use like 20 FPS that still have the same feeling. It's not like 30 frames per second, but you can still see the more like a fluid sensation in the video, but it will actually vary on each product needs. Depending on the project, if you have like more like a slow movements in the scene, you can even decrease like for 15, for example. So it will really depend on each product needs. We have other needs as well, like for example casinos, or for license plate recognition. So these special requirements will require more frames. They will need, they will have the movements that will happen in the scene are very quickly. So a car dealer, so it's very fast, the movements. So we need more frames per second to not have like a blur image in the scene. So these cases here, and as LPR as well, the car is, is passing very fast, they probably require 60 frames per second. So special requirements, of course, it's not necessarily for small and medium business, but it's a common value for this type of application. Okay. Okay, so moving on to codecs. So that's a very important codecs, a very important part of this stream. So I will start here with the MGPEG. So MGPEG, it was created in the mid-90s. It's a very old one. And basically it's a motion JPEG. So we are talking about a group of pictures compressed and sent to the NVR or to the client. So, but there's no any processing or any algorithm that it's working to decrease the size of these pictures or to try to minimize the bitrate used by the camera. It's basically using a sequence of pictures and compressing in the FPS that you selected and sending to the camera. So here's an example of a ball moving. So in each picture you get the full frame in the resolution that you selected, and it will send to the NVR. So pros and cons. So pros is it's high quality. So we have a very high quality because in each frame we have all the information that we have in the scene in the highest resolution possible, right? And another one here, less processing power. So basically we have a very low processing power on this type of codec because it's not using any algorithm or any technology to try to reduce it. It's just basically grouping and sending to the NVR. So the cons is high bitrate. So if you're not compressing, we are sending the full frame, so it's very costly to the network. So it's very you need to size your network very well to not have bottlenecks and start to have packet loss or overload. And we need storage. A lot, because the highest is the bitrate, the highest is the storage that you need to record this stream. Okay, so that's the MGPEG. So let's talk about now the H.264. Also known as AVC, Advanced Video Coding. So H.264 is a standard created by the International Telecommunication Union, and basically the summary of its principle is the camera getting the scene. It will have a component here that is the prediction. The second one is the transformation, and the last one is encode. okay? And after that, it will send to the NVR and client. So let's start to see an example here of the scene. So we have here a background, and we have a ball passing through the scene. So initially, the first one here we'll call as the iframe, intra-coded frame. So this frame will actually be the complete frame, just like the MJPEG. The complete frame with all the content, all the image as it is, without any calculation and anything. So this means that we have a low processing power, but we'll have a high bitrate, right, for this iframe. But after that, the camera will start to compare the iframe with the next frame, which is called projection frame, with the P frame. So it will start to compare the image and see, okay, the background is the same, it's static, so it will not send this data to the NVR, to the client. Only the difference, so only the ball in this case, will be sent as a P frame. So this actually will reduce a lot the data that we will transfer to the NVR and client, and this will increase the processing power needed and decrease the bitrate. And this will be the same for all the P frames that we have after that. So it will capture only the moving parts, or the parts that are really different from the last iframe sent to the camera. Okay, so basically that's how it works initially in this situation that we have a object moving, or different informations being sent, comparing to the iframe. So what's happening? After a specific time, the camera will send a new iframe with the same as the first one here, with all the information, background, etc. And this will refresh everything, because here we are just sending the extra parts that we are seeing as a movement, or that is different from this iframe, and this will update the stream to be the new frame to be compared to the next P frame. So this is like a cycle. So, and what determines this, the number of P frames and iframe, is something called GOV or GOP. Group of video or group of pictures is the same. So this is a setting that you can set in the cameras that will define how many frames I want to send, considering the iframe and the P frames. So in this example, we are setting a GOV or GOP as 4, right? 1 iframe and 3 frames. And then it will start again with the next iframe, and it will send more 3 P frames, and so on, and so on, and so on. Okay, so this is how it looks like. So what happens if we set this value too high? Depending on the type of the scene, if it's like a busy scene, a complex scene, too many movements and etc., you can start to have deterioration after a few seconds, or depending on the number of the period that you are setting here. Because we're basically sending the differences, and it's predicting how the image will look like with these new values. But only the iframe will give the real image as it is live. So if you set this a high value, it will really decrease the bitrate, but it can be impacted in the image quality. But if it's like a too low, it will be basically the MJPEG with lots of iframe, with a lot of content and a lot of data to be transmitted. Okay, and I will not go too deep on how it works, but basically we have something called master blocks, which for H.264 we have up to 16 by 16 pixels. Okay, it can be subdivided. So let's, for example, let's think this is like a 16 by 16. We can have inside of this 16 by 16 like 4 by 4, you know, and other proportions as well. And what these master blocks do is identifies similar pixels around it, and it will send the information as just one pixel. So this decreases a lot the content that we send to the NVR or to the client. Okay, so the pros and cons for H.264, basically we have less bitrate, and cons, we have more processing power that we are using, and with less bitrate we have less storage needed. We also have a new component here in the H.264 stream, which is audio. In the AMG pack we don't have audio enabled or embedded in the codec, but in the H.264 we have the audio as well. It's an option that we can enable in the camera, and it can be merged in the video stream to the NVR. Okay, so let's jump to H.265, also known as HEVC, which is high efficiency video coding, which is basically the same we know as the same codec. So the major difference, so H.265, it's an innovation, it's a new generation of this H.264. We have several different enhancements, but the major one is that we don't use master blocks anymore. We use CTUs that we can have blocks 64 by 64 pixels. So this means that we can compress more information in just one pixel and send to the NVR or to the client. Okay, so let's assume that we have in the scene a part of the sky, so it's all blue. In the H.264 we can just group 16 by 16 the same pixels, then we can send the information to the NVR. But in the H.265 we can group more pixels and send the information like blue. So it will group similar information as the same pixel. So this will reduce a lot the bitrate and a lot of the storage needed in the NVR. So pros, less bitrate comparing to the H.264, less storage, and of course we have more work going on the camera side, so we will have more processing power. And another thing related to the H.265 is that it's still not implemented as H.264 in all devices, in all services. So for example, like streaming services, web browsers to render this video, to decode this video, is not implemented in all locations yet like we have with H.264. So depending on the version, depending on the type of equipment that you are using. So for example, if you have an NVR that you are doing a remote monitoring in a web browser, normally this web browser will require a plugin if the channel is using an H.265. But this is being implemented as we speak, and we have newer generations of browsers and all the other programs. So this will probably be incorporated as we have the H.264, but it still is not widely used. So I'll put widely used. So we'll just put this as our red flag. not red flag, as a yellow flag, just to remind that if your customer has a specific need of, to monitoring this camera or this channel without a proper software to decode the H.265, you need to pay attention if it will be able to do that via a browser, for example. Okay, so this concludes our codec part. So let's talk about bitrate. Bitrate. So bitrate basically is the information that is the information that we have in the camera going to the NVR, measured by megapixel per second. So the bitrate basically it's the result of all these components that we discussed so far, which is resolution, FPS, and codec. So all this component will create a bitrate that can be 1 megabits per second, 2, 3. It will depend actually on these components that we set before. And we have two types of bitrate that we can set in the camera. The first one is the constant bitrate. So the constant bitrate, it will basically send a fixed bitrate to the NVR. In this constant bitrate, the camera will send a constant flow of information to the NVR. So one of the pros to use the CBR is that as it's a constant flow of information being sent from the camera to the NVR, it's easier to calculate the storage that we'll have for that channel. But the cons is that we are not gaining that part of the codec, that depending on the scene it will decrease the information sent by the camera. So this is not to use it when we start to use the H.264 and H.265. It really depends on each project or each need, depending on the NVR. If you have a third-party camera to that NVR, it's not the same vendor. It will not support the VBR. It will only support the CBR. So this will vary depending on the equipment that you have in the site, in the scene. But the best option would be the VBR, the variable bitrate, because it really will have a fluctuation here depending on the movements in the scene. It will have a lower bitrate, and when we start to have movements and new components to that scene, it will increase the bitrate. But of course, in most of the cameras, we have the maximum that we can set for the channel. So if the camera will need to exceed this limit here, camera will start to decrease the quality to not send more bitrate that is defined here in the max bitrate for the VBR. So in summary, these are the components that we have in the video stream, and knowing better now, you'll be able to understand what kind of resolution you really need in your project, to not put everything in the high-res resolution, to really understand each scene if you really need that resolution. FPS, same. So if you really need to have the fluid view of movements in your scene, or if you can have in a little bit robotic mode, but it will save a lot of space and bitrate. The codec used as well, depending on the camera. If it's a very cheap camera and if you set H.265, it will start to not have necessarily issues, but it decrease this camera capability to do other tasks as well. So it's very important to check if your camera support H.265, for example. Check if using H.265 at, for example, 30 frames per second, if this setting will not impact in any other features this camera has. Okay, and I think that's it. I'll see you in the next class.